Okay, so I would like to thank you for invitation for this conference. I have one question. How many of you know about R? How many of you are using R every day? Okay. So I will tell something about R because not everyone knows about it. So I will start with an introduction and then I will switch to presenting a tool for managing R software projects. But before I will go to this, I would like to explain what I mean by R software project. How many of you are in advanced analytics? One person. Okay, so how many of you are game players, computer game players? Nice, much more. Okay, so what I wanted to say and why R, I wanted to say that open source now is a real leader in advanced analytics, and I will prove it during this presentation, so you can understand what I mean by this. The leadership is because of two things. One thing is GPU, that's why I ask about computer games, and the second is community. This is a slide showing the tools I find the most disrupting in advanced analytics. In the middle is R, because I've been using R for 12 years now. But you can put any other tool on the slide. I didn't put Python on the slide because I don't find it as a disruptive in advanced analytics. Do you know those tools? Do you know this tool? H2O. Okay. Okay, so let's switch to the example on this leadership. Sorry. So this is a movie prepared by H2O. H2O is a company that is building open source machine learning framework. And what they show on this slide, they show the power of GPU. So on the left side, you see the speed of computing on GPU. If you are not in advanced analytics very well, so I will not go into deep details. But what I wanted to say, this slide shows that with GPU now, I can have better models much faster. As you can see, GPU is in the middle of work, and CPU didn't even start. And this is about 40 cores working. Xeon is 22 CPUs. One graphic card is a few thousand CPUs. So this is the power you can see on the slide. And that's what I wanted to say, that open source is a leadership. So this is, of course, a teaser for my friends from big vendors. But this is what I can have using R and what we deliver to our customers with open source environment, R and friends. Okay, so what is R? From a computer science point of view, this is just a dynamically interpreted programming language, not very well designed. My friend, who is a very experienced programmer, says that it's not a design that makes a language popular. So you can have very poorly designed language, yet it can be very popular. So R is a dynamic programming language. What is more important is that it's open source product, very stable product. If you think about stability in computer science, It's a product we have delivered, using R, we have delivered a solution to Deutsche Bank. It has been 7 years ago, and it's still working without any big problems. So open source done right can be very stable. What is nice and why we use R, it's because it's very easy in R to do data analysis. In all projects we deliver, we have to ingest data, transform data, export data, run models on the data, using the data. And in this language, it's done easier than in other languages we tried. It's not perfect, of course, but it's better. Okay, so this is an example of R language. On the left side, this is a dplyr, very famous package in R. So if you are using R, you should be aware of this. As you can see, this is very clear syntax to read. Do you understand the code on the left? Or you can guess the meaning. If you are using SQL, you should understand it. And on the right is, if you are in advanced analytics, you should notice that this is a deep learning model declared in a high-level language I have designed when I was playing with Microsoft deep learning library, CNTK, and it took me 2 hours to get this syntax. And this is a real power of R. This power means that I can build my domain-specific languages very easily, as you can see. So this is data preparation, this is architecture of my network, and this is very clear to be read. You can try to do this in Python. What is next very, very important about R is a community. R is about, it's estimated about between 2.5 to 3 million users. So it's really, really popular. I don't remember the place, but when you check with Tiobe index, you can find it very high, I think, maybe 10 or 6th place as a popular language. And community gives us fast problem solving feature. I have a story about other vendor. I will not use the name, the 3 letters. There are 3 companies on the market that are delivering advanced analytics packages having 3 letters in the name. And there was on LinkedIn, my colleague posted a post with a bug in a software, and it still hasn't been solved. In open source, we can solve it having access to either community or ask them or do it by ourselves. What is else about community is that R brings you a vast amount of packages. Package is from other computer languages, is a library that gives you additional functionality. I believe this number should be about 12,000 packages. Of course, as with open source, you have to be aware that some of the packages are just crap, so you shouldn't use them, but a lot of them are very useful. And very often, if you want to experiment, or you are thinking about a method, you can just go to a CRAN, and CRAN is a public repository or official repository of our packages. What is else becoming more and more popular, unfortunately, is a GitHub. Unfortunately, because it's bad for software development best practices, using software from such sources, but I cannot change this, so I had to adapt. So on GitHub, you can have more and more packages. for R. And this is community. But if you want to go further and not write few liners as you've seen before, you find that open source R doesn't give you anything, or not much. Not anything, but not much. And for you to understand what I mean by this, I will give you some slides. After this, I will show you the solution of the problem we made for us and decided to share it with the community as well. So what I mean by large scale in our software development. So when you are thinking about scripting languages, like, for example, Bash or R, you are thinking about few liners, just to help you to do some automation. And in R, it's just when you look at the books or some trainings, you have very short pieces of software that can help you build a model. I'm talking about writing a software. So you have a structure, you have a module, you have to control everything in this. And the difference is, I don't know, small scale is about 1,000 lines of code, and large scale is 10,000. This is not much for a Java programmer, but R is a very, very in R you don't write this amount of code in general. So for example, in Deutsche Bank, I mentioned before, it was about 20,000 lines of code, and the biggest solution was about 30,000 lines of code. And I will show you the example of some workflows we have implemented in R. So you can understand about how we came back with this amount of lines of code. But this is a difference when you write 100 lines of code or 1,000 and 10,000. You have to start thinking in this on structuring your solution, on maintaining this solution. So the examples. So it was a workforce optimization. So imagine you are a retail owner, retail chain owner, and you need to optimize amount of people in each store. So what we had to do, we had to build 3 models, what we called efficiency curves. Traffic, it's when you enter each store, you are measured. So we had to measure this traffic of incoming customers. And the last was a decision module that took everything, including business rules and human intervention, because human always can say something to generate the result. So this is not a trivial workflow. This is a pipeline, because in most of our solutions, this looks something like this. That's why I don't need object-oriented programming in R. I need pipeline. But this is something you have to prepare, control the quality of the data that is incoming. This is a solution that it's installed and it's running every day. So it cannot give you a bugs that you cannot control. And everything gives you the amount of code. Of course, in some places like traffic forecasting, there is one liner of building a model, but you have to prepare the data, control the quality of the data, consume the results, and this takes space. The second is I think it was the first big implementation of R. It was for cache optimization in Deutsche Bank. Cache flow optimization, I mean the real cache. You can touch the cache. So it wasn't a really financial project. It was more logistic project. As you know, bank is a logistic company. So it's also quite quite complex. I'm not talking here about, parallelizing computation or this stuff. To have this running in a smooth way, you have to do some obvious things. But I wanted to show you that the structure of the solutions, complexity of the solutions, forced us to think about the solution, to think how to reorganize our development process. If you are a consulting or a software development company, and you deliver such a solution in scripting language, dynamically typed or almost without any types, you have to think how to defend yourself if the customer says there is a bug or the solution looks strange. So this is why we were thinking how to fix software development with R. Okay, so the last is implementation of R for data science team. It was a replacement for SAS, advanced analytics part. So the data science team was before using SAS for building models. Now they can do both now, to be true, but they don't do SAS now. So this was a different setup. I wanted to show it to you so you can understand that the product we created helped them also. So there are many users working on the same resource. This is a server, physical server. This is a project. I will explain later what I mean by this project. They are separated. That's why I draw it like that. They have a continuous integration, version control, all the stuff. Every software developer, even junior, knows. But in our world, they don't know this. So this should be only this way. So what you can see on a production, this is completely separate. This is not connected to anything. You just put a solution. You don't install any packages here. It just R here. And this is a resource manager, resource monitor. It was developed by us to monitor how many resources the users are using. And the solution we used and what we brought to the customer, the experience we brought was how to deal with our software development. And each box here, it can be a churn model. So if you are leaving this company, those pieces of code are signaling the company to call you and give you a next best offer of your life. So they wanted to build this in a such way that they can maintain this in a long term. Okay, so as I said before, R out of the box doesn't give you much, but it gives you still something. What kind of software development process I'm talking about? So this is a development environment. So you are playing there with your new ideas. You use a version control when you commit a new version of the code. Then it goes to a continuous integration and deployment service. Depending on the company, on your processes, it can either be automatic or not deployed on a production. And in fact, this kind of software development process is as I said before, for a Java or .NET programmer, is something that they understand. In our world, they don't understand this, and analysts are not programmers in an essence. They don't know how to program. So they need to be taught this. And in this kind of software development process, our software development process for R were designed. But what is nice about R, and this is really nice, if those who are using R, those who are using R knows what I'm talking about. R has packages, and packages have a help system. So when you give a package to another person, they can ask about the help using a standard tools in R. In using packages, you can declare dependency. So you can say that my package depends on the other package in version 2.5 exactly, or 2.5 and 5 and later. You can in packages also store some data and give it to someone else, which is sometimes very convenient. Vignettes is a part of package help system. It's a kind of short article showing how the package could be used. And in each packages you can have tests. And I'm talking about typical unit tests. And when you check the source code of RSuite, you can see the test of RSuite itself. Okay? And this is nice thing because it's out of the box. So we are using this for having a good quality software. What is not nice about R? Those of you who are using R, can you tell me what is not nice about R? When you want to write a software in R and give it to someone else to use it. Okay, so this is how looks development environment in R. Key. So you have a sources of packages, your code, environment, probably your local source of packages. And here, when you install a package like this, it's installed in one place. And the problem is that in R, you cannot install two versions of one package in one place. And this is problematic because very often when you install R, it in default installs packages in one place. For example, either in a global directory or in your local user directory. So this is a problem, how to give your customer list of packages and tell them how to install the packages so they don't mess with in the environment they have. Okay, so yesterday I had another conference, but I had to come here, so I missed the party. But I did refactory of a solution drink R. It's just, you can play to see how much alcohol you have in your blood in time. So you can play with drinks in time. And what is nice, I have prepared a package for you using RSuite. You can install vanilla R. This is important. Vanilla R, I mean just R without any packages. Download this package and follow the instruction, and then you can see the result. And I can do this for you. Or not. And this, wait a second. I need to change a provider. So what this example shows that, wait a second, that you can prepare a package for a person that has a vanilla R, and as I said, on production server, you want to have it clean as much as possible, and you can just run it, because everything is inside the package. So let's Okay, so I have an emulation of production environment. After this example, I will walk through my product. As I said, this is open source. You can Apache license, so you can use it for your own purposes. We are waiting for your comments, and I wanted to show you the okay, so I have downloaded, unzipped. Okay, and we can start party. So this solution was, as I said, you can download it on your and this is important. Try it with Vanilla R. So with Vanilla R, you don't have any packages. Everything inside the package, and you can run it like this, and it's fully working. So we can add a drink. I'm not the author of the functionality, but I thought that this conference and this is Friday, so this could be on time. And this is what I like the best in our solution. So I can make a deployment package without any problem. This is just one instruction, and it's working. No package installation. Okay, so let's go through the sorry. Okay. Through the solution. If you want to follow, you can just download R. You can use the newest. We have tested this with version 3.3, but it should work with almost any. You can download the solution. You have the link. After downloading, you have a short instruction how to install this. And okay, so what's the development cycle? So we are playing with a project. I will go deeply through the project structure because this is the most important part of the solution. So you are starting a new project. What is nice, if you start this project in a Git repository, it will be added to the Git. If it's in SVN, it will be added to SVN with all those Git ignore tags that is important. So you will not finish all those packages committed to source version. What is also nice, if you are using Git or SVN, when you make a deployment, the revision number is added to the package version. And then you build a package, you add a package, you develop a package, you add some dependencies, you can build your packages, and then you build a deployment package. Of course, you should have some tests, but it's, it's a cycle, so. Okay, so when you start a new project, this is so I'm in a I understand you don't see this, right? Can you see it? Okay, so this is a sandbox, and I will start a new project here. What is happening now? I'm using, do you know Anaconda Python distribution? How many of you know? A lot. Okay, big data, right? So this is very similar to Conda. I mean, the idea of command line client. All the functionalities is in an R package, so you can use it from R directly. And this tool is not doing anything smart except running R script with our package. So we have started a project. You can see that in the folder I have a project, and it has some structure. So let's see what's the structure of the project. So the project has a folder deployment, and this is the place all your packages, external or your internal, are installed. So each project has a separate place of where the packages are installed. The second is a logs. This is where all the logs from a logging engine are put from your solution. Again, very often when I refactor some R codes from my customers, I have to remove a lot of print functions. So this is a problem because a lot of people are using print to debug their code, which is, of course, not a very good idea. So we are using logging infrastructure for this. Next, you have a folder with your packages. And this is important because we are forcing the user to write all the logic in a package. So you have to structure your code. No 3,000 lines, nice code. Make 2 packages. Think about this, okay? Next is R, where master scripts are stored. Master script is, if you know Python or C or Java, in each of those languages, there is something called main, right? So this is main. So you write in a package all the logic you need, and in main you just import packages and call the functionality you want. This is important to keep your master script clean as much as possible. The last is a folder with test. You can have also additional folders as you wish. Those folders that you can see above this dotted line are a standard part of our project. The last 3 is, common practice when I do an analysis project. So for example, I'm developing a model, so I have to get some data. If the data is small enough, I just put it in an import folder. When I build a model or a report or Excel, I put it in export folder. And also when I do some steps of calculations, okay, so one important thing, you can have many master scripts, so I can make few master scripts to build the full functionality. So each master script can give me some partial work, partial computation, partial results, so I can store it in work. And of course, work, I can clean it and rerun all the process, okay? And this is a good practice when you do data analysis, and this is for, software development, and this is a standard project structure. So, what is next? So those were the folders I was talking about. As you can see in deployment, there is some other folders. In libs, in deployment libs, you will see the packages installed. As you can see, there is one package already installed. We have no packages. We have only one master. What is else? We have parameters file. So parameters file are meta parameters of the project. You can build, for example, you have your official R version is 3.4, but you delivered the solution 1 year ago with the version 3.3, so not to have problem or trying to make a development environment similar to production, you can say that you will be developing for this version. So if you have it installed, you can use for RSuite one version and develop for different. You can say where are your packages, repositories. This is Microsoft service. And you can also say about artifacts. I will tell you more what's this. So you can have different repositories, and this is really important. There is no GitHub, and it will be not. You have to deal with GitHub in another way. So you can have Microsoft, you can have S3 or any other URL, and you can have a local directory. So for example, in a company, you can have a, I don't know, network folder with company packages. Artifacts, this is something that should be added to a deployment package. So for example, with this alcohol concentration application, when you select a beer type, a drink type, this is read from CSV file. And when I prepared a deployment package, the CSV file was added as an artifact. Okay? Next is configuration. So the only default parameter now in configuration is logger level, but you can add some other configuration things. The configuration is what you change when you make a deployment. So when you configure a deployment on a production, you can tune the configuration. So for example, paths or something like this. Okay, so I started a project. I have a master file, so I can run it. And I run it using R script, and this is recommended way of using R. For those who are using RStudio, it could be a shock, but yeah, this is where you are sure that the environment of R is clean in this way. So as you can see, it ran. It did nothing because it's empty. It's not really empty, but almost empty. Okay, so let's see the master file. In meantime, what is also nice, when we build a project, we create RStudio, we create RStudio project files. So for those, and this is one of the most popular IDE for R, you can just use it for developing your own code. So I click this, double click this, and I have RStudio running, and this is how master file looks like. All the instructions in the beginning should be there. Probably we could do this the other way, but those magics should be here. What is important, the script auto-detects where it is. So when you run this script, in a script path variable, you know that this points to your master file. And this is very convenient when you have some other folders in the project, so you can give a relative reference from the script path. Okay? Okay, so when you put all logic in your packages, you have to add a package. For those who are how many of you of those who are using are using packages in everyday? 1, 2, okay. So with this tool, it's completely easy to use packages. So I created a package, and it's stored in a packages folder. You can see it's prepared and with proper structure. So I can use RStudio to develop code there. So as you can see, the description of the package was prepared for me. What is important is adding logging, because with RStudio you have logging by default. So you have this package, and let's switch to to master. I made a mistake in the name of package, so I have to use. Okay, so try run this. Can you see the error? So the R is saying that you don't have this package, because you have to do one more thing to see the package in a master file. You have to build the package. So what's happening now? You will see the output, and you should understand. What's happening now? The RStudio can see that you have a new package. It uses R to build it and stores in a libs folder. So let's try to use Okay, so now we don't see an error. So the package was built, and you can use this in master. So now we can add a function to a package. Let's add a simple function. And you do this as in a Let's make it one time. And this function is doing nothing interesting. It's just printing hello plus string given as an argument. Okay. So wait a second. I have to. Let's run it. So as you can see, it's not running because we've built a package without this function. Okay? How to deal with that? You can deal with that as before. You can rebuild your package. Yeah. Nice. Okay, let's do it the other way. So as I said, I tried to build this, it didn't work. So we have a situation that we cannot have some probably bigger issue. So let's switch to RStudio to fix the. Can you see the screen? Okay, so as I said, you can use DevTools. If you are developing packages, this is the tool you should be using. So what I'm using now, I loaded the package. I can debug it and fix it. So as you can see, we have a problem in sprint function. So the problem is that I misplaced. Let's try it. Well, it works now. Okay, so hopefully it will build. Did you follow me? So what is nice, I can use DevTools to fix the package, because as is in R, to have a new functionality in a package, you somehow have to reload it. And either you do this in a standard way, so you build a package, install it, or you can use DevTools to do this in a dynamic way. So now we have it running. Let's see if the output is as we expected. So yeah, it's hello DataMass. What else? How many time I have? How much time? How much time do I have? Okay. So, what I wanted to show you next. Let's add some dependencies. What I put here, I wrote that my package depends on a package data table in version at least 1.10.1. This is in R. This is in every software, every language. This is really important. I will show you the example why it's important to play with the versions. So this is the data table is very good package. The developer behind the package is a professionalist, and he openly told us that in this new version he changed 3 functions: unique, duplicated, and unique. Unique and duplicated are, you know, scanning a table like in Excel and telling you if any rows are duplicated. And what he did, he changed that. Before he was using key to answer the question, and after the change he was using the whole row. So it's completely different functionality. That's why you have to control the version of the package. Okay? So I added the package, so I go back to a standard situation, and I cannot build because it tells me that I have some dependencies that I don't have them installed. So what I do, I install dependencies. What RSuite is doing now, we gave only one repository. We can have fewer repositories, so it's scanning the repositories, finding if you can have what dependency you have in your project, and install them for you. So the result is, so in Ellipse you can see a data table, right? So build it. Now build works because we have data tables, so the dependency was installed and the version was fine. And yeah, as you can see, it's loading data table package. So we can use the data table package in your solution. The last thing I wanted to show you are the loggers, because I think it's important to use them. They are standard loggers, so I will put just 2 of them. Okay. I just changed master, so I don't have to build anything. And as you can see, on the picture, the info logger. So to see debug, we have to switch to config. Change it. And you can see a debug from a master file. What is nice else is that when you add a package, you can use package loggers as well. There is a bit different syntax. There is a prefix, package underscore, so you can know this is for package. I will put the 2. So you can have both debug and info in your package, and you will see the output. And I think this will be the last thing I wanted to show you. And as you can see, go away. As you can see, each package, when we create a package, we configure loggers with the name of the package. So when you scan the log file, you can see if the log info was from this package or the other. Okay, very convenient if you want to debug your software. And the packages, the logs, as I said, now are stored in a logs file, and they look like this. Okay, I think it was everything I wanted to tell you. It was just a basic scan of RSuite. I didn't cover repository management. One thing I will show you. Okay, sorry. This is important. How to make a package, deployment package. So I'm not in a Git or SVN repository now. So I had to add a version number. So if you are in a professional environment, it adds this in an automatic way. So now I have my project zip. I can give you any one of you, and you can run our solution on your own computer. Okay, so thank you. This was everything I wanted to tell you about, and please test it. Find bugs, make it better. Okay, thank you very much for your attention.